Okay, so we started with quadratics for the type of polynomial, and you just did, checking on how to solve and graph quadratics, second degree polynomials. We're going to go with higher degree polynomials, third degree, fourth degree, fifth degree, and talk about how we find the zeros of those and how we graph those. So we'll start with something we're more familiar with. Is 5 a factor of 30? Hopefully you all said yes. Okay, how do you know that? You know that because 5 goes into 30 6 times with a remainder of 0. Right? And we don't have to go through all that. We just know 5 times 6 is 30. Therefore, 5 is a factor of 30. So we're going to be asking you questions about binomials, like is x minus 3 a factor of this third degree polynomial? Well, if I can take x minus 3 times something and get 2x cubed minus 6x squared minus 50x plus 150 with a remainder of 0, then yes, it's a factor. It's the same question, okay? We're wondering, is there a way to write this as a product with one of the factors being x minus 3? There are two ways to tell this: long division and synthetic division. In long division, it works very similarly to how we learned long division in elementary school. I'm thinking, all right, I'm just going to look at the x. What do I multiply x by to get 2x cubed? Well, that would be 2x squared, right? 2x squared times x would give me 2x cubed. Well, I also have to take 2x squared times 3, which is negative 6x squared. And now I'm going to subtract. Remember, I'm subtracting this whole term. So I'm going to distribute the negative through. Okay, and then add. 2 and negative 2 is 0, negative 6 and 6, I have 0x squareds. I'll bring down the minus 50x. So now I'm thinking, okay, what do I multiply x by to get 50x, basically, right? And that would be 50. 50 times x is negative 50x. I'm sorry, it's a negative 50. Negative 50 times x is negative 50x. Negative 50 times negative 3 is positive 150. I would, of course, bring this positive 150 down as well. When I subtract, that's adding the opposite. Well, great, I get a remainder of 0. So basically, I just found out that x minus 3 times 2x squared minus 50, if I multiply that together, I should get this third degree polynomial. I might double check that. That's 2x cubed, x times negative 50, that's negative 50x. Negative 3 times 2x squared is negative 6x squared. Negative 3 times negative 50 is positive 150. So yes, 2x cubed minus 6x squared minus 50x plus 150. Great. If I would have done this with synthetic division, then I just take what I was subtracting from x. I was subtracting a 3 from x, so I'm just going to bring a 3 here. If I was dividing by x plus 3, then I would use a negative 3 there. Okay, it's the opposite of maybe what you think, but it's whatever's being subtracted from x, you put here as your multiplier. We take all the coefficients of my polynomial, 2x cubed minus 6x squared minus 50 plus 150. You bring the first term down, okay, to get started, and then you just multiply and add. So 2 times 3 is 6. I'm going to add negative 6 and 6. I get 0. 0 times 3 is 0. I add negative 50 and 0. I get negative 50. Negative 50 times 3 is negative 150. I add 150 and negative 50. There's my remainder of 0. what I have left here are the coefficients 1 degree less than what I was dividing into. I was dividing into a third degree polynomial. So this is 2x squared, 0x's, minus 50, which of course we just write as 2x squared minus 50. Okay, we have, which is what we got here as well. Okay, but the key is knowing that the remainder was 0. Another way we can know the remainder, maybe if we don't need the other things, I can know the remainder is 0 by just putting in the c value right in for x in my polynomial. If r is the remainder, when a polynomial is divided by x minus c, then r equals p of c. So since I wanted to know what the remainder is when I divide by x minus 3, okay, that was the question. That's what I was trying to find back here. Is x minus 3 a factor, right? That was the question. So I'd like to know the remainder. They're saying, hey, just find p of 3. Stick 3 right in for x. Okay, so I'm going to put 3 in for x. You can pause me and try it yourself. 3 cubed is 27. 3 squared is 9. 2 times 27 is 54. 6 times 9 is 54. If I add this together, 54 minus 54 is 0. Minus 150 plus 150. Yep, p of 3 gave me 0. So I wouldn't have had to do all that long division or synthetic division. I would be able to say, yes, x minus 3 is a factor because the remainder is 0. And the way I know that is from this remainder theorem that tells me if I want to know the remainder, I just stick c right in the polynomial. Now remember, if I was dividing by x plus c, then I would put negative c in the polynomial, okay? Be careful with that. All right, so we can answer our question now. We know, yep, it's x minus 3 is a factor. Now, one thing, if they do want it in factored form, then I would have had to have divided like I did with the long division. X minus 3 times 2x squared minus 50. And then that's not completely factored because I could bring a 2 out of the 2x squared minus 50 and just write that as x squared minus, what, 25 if I take 2 out of this and I moved it out front. Well, now that's the difference of 2 squares. X squared minus 25 is x plus 5x minus 5. So to write this in factored form, I have to go back and kind of remember a little bit more about my factoring, difference of 2 squares, or if I have a perfect square trinomial, anything like that that happens here. To sketch the graph, well, now I know my zeros. I know where this equals 0. It equals 0 when x is 3, negative 5, and 5. So at 3, 5, and negative 5, I know I'm crossing, I know that y equals 0. Okay, 3, negative 5, and 5. Other things I know is that when I put 0 in for x, I get 150. 0, 0, 0. Okay. I also know it's a third degree with a positive leading coefficient. So it's going to start out here, right? And again, end up going this way. So it looks like I'm going to have something like this. Okay, hitting all my points. I would need to maybe plot a couple more points. I might want to know maybe what 4 is. Just maybe put 4 in and see what we get. I might want to know, if I go higher than 150. But again, I have a pretty good idea just from the zeros, the x-intercepts and the y-intercept. I have an idea of what this graph looks like by being able to factor it. Okay. So again, you would have to, put some more points in. You have your calculator. It's nice to find, I find a couple other points. I might find something, maybe put -2 in, maybe put 4 in, just to get some more exact points. I, of course, just did it on Desmos to see. And as you see, I had a pretty good graph, I thought. -5 is where it went through. And of course, 3 and 5, we had that same thing on our graph. Okay. -5, 3, and 5. Of course, we knew it went through 0, 1, 50. But what I kind of had it coming up and just hitting there. I missed this chunk. The rest was pretty much the same, but I didn't realize that it went higher than 150. Okay, I should have, like I said, it's good to put a couple points in between your zeros so that you have an idea. Okay? So that's where writing it in factored form comes in handy so that we can get the zeros, etc. Okay? Now, if we're not sure what to use, like I had already said, x minus 3. I said, is x minus 3 a factor? So we already had somewhere to start. And we have somewhere to start here. But if you don't, then there's the rational zero theorem, which tells us that if you take the constant term, a sub 0, and divide it by the leading coefficient, okay, the constant term, a sub 0, and the leading coefficient, a sub n, and we make them as a fraction, a sub 0 divided by a sub n, which they're letting a sub 0 be p, and they're letting q be a sub n. So they're saying p over q. Any of those factors are potentially a factor of the equation, okay? So is x minus 4 a factor? Well, let's list all the possibilities that we have based on the rational zero theorem. I'm going to take 8, because that's my constant term, divided by my leading coefficient of 1. And those are all the possibilities, okay? Any factor of 8. So what would that be? 1, 2, 3 doesn't go into 8, 4, and 8, okay? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possibilities. And look, 4 is one of the possibilities. Now, I'm not sure if it's a factor or not. A couple things I could do. I could put 4 in and see if I get 0. Some people like to do that. They just put, they're like, I'm not going to waste my time with dividing until I see for sure, is this, does this have a remainder of 0 when I divide? When I do 4 to the 4th plus 2 times 4 cubed minus 4 times 4 minus 8, I ended up getting 360. So, no, that's not a factor. Okay. So let's find the factors. I'm going to use synthetic division with my coefficients of 1x to the 4th, 2x cubes, 0x squareds, -4x's, and then -8. You have to have one spot for every degree less than what you started. Okay, so since I started with a 4th, I needed a 3rd, 2nd, 1st, and a constant. So even though there's not an x squared, then I put that with a 0. Okay. Now my things I'm checking again were positive and -1, positive and -2, positive and -4, positive and -8. Let's just start with 1. See if that works. When I bring 1 down, 1 times 1 is 1. Add these together, I get 3. 3 times 1 is 3. Add these together, I get 3. 3 times 1 is 3. Add these together, I get -1. -1 times 1 is -1. Add these together, I get -7. Nope, 1 didn't work. That didn't give me a 0. Let's try -1 while we're here. Bring the 1 down. Okay. And then do that multiplication. So 1 times -1 is -1. 2 plus -1 is 1. 1 times -1 is -1. 0 plus negative 1 is negative